Hello students, this is a continuation video lecture on the topic problems using theorems under Laplace transform. Previously we dealt with problems using the first shifting theorem. Now here we will be using the theorem 2 under Laplace transform. The question here is find Laplace transform of t sine at. We see that we have to find the Laplace transform of product of two functions where one of the function is t. So this is of the form L of t multiplied with f of t. So we have to apply theorem 2 in order to solve this problem. So according to theorem 2, we know that if we want to find the Laplace transform of t multiplied with f of t, it will be equal to negative d by ds of Laplace transform of f of t. So, we have to find a Laplace transform of f of t and differentiate it with respect to s, and we have to multiply with negative 1. So, this we have to do now. So, now if you see here in our given question, we have to find Laplace transform of t multiplied with sine at. So that means f of t is equal to sine at. So f of t is sine at. So this will be equal to negative d by ds of Laplace transform of, what is f of t over here? It is sine at. So sine at. Now this will be further equal to, now if you see what is Laplace transform of sine at, so by the results using Laplace transform, we know that, so this will be equal to d by ds of the Laplace transform of sine at is equal to, by the formula it is a divided by s square plus a square. So this is the result that we already know. So a divided by s square plus a square. Now we have to differentiate this with respect to s. We can use u by v method and differentiate this, or we can take s square plus a square to the numerator, which will be raised to the power minus 1, and we can use the formula x to the power n, the differentiation of x power n. So in these two ways we can differentiate this. So as of now I will use u by v method, because when we have cos at, it will be s divided by s square plus a square, where we definitely have to use u by v method. So if you see, we know that the differentiation of u by v with respect to any variable will be equal to, we will have v square in the denominator and then v multiplied with u dash minus u multiplied with v dash. So this is the formula, that is the formula from differential calculus. Now here if you see, what do we have at the place of u? We have u to be equal to a. And what do we have at the place of v, that is the denominator? It is equal to s square plus a square. So we need u dash and v dash. So u dash is the differentiation of this. But this is a constant, so it will be equal to 0. V dash is the differentiation of v. So if you see here, we are differentiating with respect to s. So s square we have here. So the differentiation of s square is 2s plus a square is a constant, so it will become 0. So now we have to substitute in this formula. So let us do that now. So this will be equal to, now by using this formula, we have v square in the denominator. So it will be s square plus a square the whole square. And then v multiplied with u dash. What is v? S square plus a square. So this has to be multiplied with u dash, which is 0. And then minus u. What is u? It is a. So a multiplied with v dash. V dash is 2s. So multiplied with 2s. And so that will be further equal to, so s squared plus a squared multiplied with 0 will give us 0. Minus a multiplied with 2s. So 2as divided by s square plus a square the whole square. But we have to observe that we have a negative sign here. So we should not forget to put that negative sign. So here also we have a negative sign to be multiplied with this. So when we multiplied that negative sign, so anyway this is 0, minus into minus becomes plus. So 2as divided by s square plus a square the whole square is the solution for the given problem. So we shall do problem 2 now. So here we have problem 15, that is we have to find the Laplace transform of t sine 2t. We have to find the Laplace transform of product of two functions where one of the function is t. So it is of the form to find the Laplace transform of t multiplied with f of t. We know that this is equal to negative d by ds of Laplace transform of f of t. So we have to apply this theorem now. Now in our question it is given that we have to find the Laplace transform of t sine 2t. So we observe that here f of t is equal to sine 2t. So therefore it will be equal to negative d by ds of, we have to find the Laplace transform of sine 2t. But by the formula of Laplace transform, we know that the Laplace transform of sine 2t is equal to, sine at is equal to a divided by s square plus a square. So we are going to apply this formula now. So when we apply this formula, so this will be equal to negative d by ds of, what is Laplace transform of sine 2t? At the place of a we are having 2. So it will be 2 divided by s square plus 2 square. So therefore that will be equal to negative d by ds of 2 divided by s square plus 4. Like in our previous video lecture where we saw that the differentiation of u by v was equal to v square v multiplied with u dash minus u multiplied with v dash. So here if you see we have u by v where u is what? 2. So u dash will be equal to 0 because it is a constant. V is equal to the denominator which is s square plus 4. So v dash will be equal to the differentiation of this. Differentiation of s square is 2s plus differentiation of 4 is 0 because it is a constant. So therefore this will be equal to, so after differentiation we have to apply the formula, this formula. So negative, because we have a negative sign here already. So negative multiplied with, we have v square in the denominator. What is v? It is s square plus 4 the whole square, and then v. So v is s square plus 4. This has to be multiplied with u dash. What is u dash? It is 2. U dash is 0. So multiplied with 0 minus u multiplied with u is 2 multiplied with v dash which is 2s. So this term will be 0, so we need not write it, and minus into minus will become plus, and 2 multiplied with 2s will give us 4s divided by s square plus 4 the whole square. So therefore this is the solution. So here we have problem 16 where we have to find the Laplace transform of t cos 2t, which is a product of two functions where one of the function is t. So this is of the form Laplace transform of t f of t. So by the result, by the theorem, we know that it is equal to negative d by ds of Laplace transform of f of t. So we have to apply this theorem in order to solve this problem. So we have to find the Laplace transform of t cos 2t. So at the place of f of t, we have cos 2t over here. So this will be equal to negative d by ds of, we have to find the Laplace transform of cos 2t because f of t is cos 2t over here. So by the formula, we know that the Laplace transform of cos AT is equal to S divided by S square plus A square. So we are going to apply this formula over here. So when we apply that, this will be equal to negative d by ds of what is Laplace transform of cos 2t. At the place of a, we are having 2. So it will be s divided by s square plus a square, which is 2 square, that is 4. Now we have to differentiate this with respect to s. If you observe, we have s by s square plus 4, for which we have to use u by v method. That is, differentiation of u by v will be equal to v square in the denominator, then v multiplied with u dash minus u multiplied with v dash. So here we have u to be equal to s and v to be equal to s square plus 4. So we have to find u dash and v dash. So u dash is the differentiation of s with respect to s is 1. And the difference v dash will be equal to the differentiation of s square, which is 2s, plus the differentiation of 4 is 0. So we need not write it. So this is 2s. So therefore this is further equal to negative. So because we have a negative sign here, we have to write that. And then d by ds of this, that is du by v formula we have to use. So it will be, what is our v? V is s square plus 4. So in the denominator we have s square plus 4 the whole square. And in the numerator v multiplied with u dash. V is s square plus 4 and u dash is 1. So multiplied with 1 minus u multiplied with v dash. U is s multiplied with v dash is 2s. And so this will be further equal to, on simplifying, we will be having s square plus 4, this negative sign we will have, minus 2s square divided by s square plus 4 the whole square. So on simplifying further, we get this to be equal to negative of, we have 4 and then s square minus 2s square is minus s square divided by s square plus 4 the whole square. Now carrying this negative sign inside, we will be having negative 4 and minus into minus will become plus. So plus s square divided by s square plus 4 the whole square. So this can be rewritten as s square minus 4 divided by s square plus 4 the whole square. So this is the solution of this problem. So next is problem 17. So now here we have problem 17 where we have to find the Laplace transform of t sin h at. We are applying the same theorem because this is a product of two functions where one of the function is t, and so this is of the form t multiplied with f of t. So therefore f of t is sin h at. So applying this theorem, we get this to be equal to negative d by ds of Laplace transform of what is f of t? Sin h at. We know that the Laplace transform of sin h at is equal to a divided by s square minus a square. So we are substituting that here. So negative d by ds of Laplace transform of sin h at is a divided by s square minus a square. Now we have to use the differentiate this using u by v method. So we know that the differentiation of u by v is equal to, in the denominator we have v square, in the numerator v u dash minus u v dash. So applying this, we use like previous problems, in the same way we get the solution here as 2as divided by s square minus a square the whole square. Similarly, let us do problem 18 now. So now we have problem 18 here, which is the last problem of this video lecture. So here we have find Laplace transform of sin at minus at cos at. Now here we have to apply the linearity property and take the Laplace transform of each of the functions separately. So that we have done here. So Laplace transform of sin at minus at cos at can be written as Laplace transform of the first function sin at minus a is a scalar which can be taken out. So by using the scalar property, it can be taken out. So we get Laplace transform of t cos at. So the two properties that we have used here is linearity property and scalar property. So let me write that here. So I have written these two properties we have used. Now next, what is Laplace transform of sin at? We have to use the result, that is Laplace transform of sin at. We know that it is equal to a divided by s square plus a square. So we will be using this result here. So we have a divided by s square plus a square and minus a multiplied with, we have here Laplace transform of t into f of t. So what is the formula? That is by the theorem we know that Laplace transform of t multiplied with f of t is equal to negative d by ds of Laplace transform of f of t. So this we have to apply here. So we have negative d by ds of Laplace transform of what is f of t? Cos at. So that we have written here. So this remains the same. So here by mistake I have given a plus here. So this is negative. So this will also be negative. So negative a multiplied with, no, actually what I have done is minus into minus has become positive. So this is plus only. So plus a multiplied with, so this negative sign has gone now because we have multiplied these two and it has become positive, d by ds of what is Laplace transform of cos at. So by the next formula that we will be using here is Laplace transform of cos at, which is equal to s divided by s square plus a square. So applying that formula, Laplace transform of cos at is equal to s divided by s square plus a square. Now we have to differentiate this as we did previously in our problems. In the same way, I have used u by v method. So here u is s and here is v is s square plus a square. So I have used that formula over here and we have solved this problem. So after this, so on simplification, we get in the numerator as a square minus s square divided by s square plus a square the whole square. Now if you see in these two terms, in the numerator a is common, so it can be taken. In a similar way in the denominator, one of the s square plus a square is common here. So that also can be taken out. So within the bracket, because these two terms we have taken as it is outside, it becomes 1 plus. Now here what is left out? A has been taken out and one of this square, we have square here, one of the term has been taken out and so we will be left out with a square minus s square divided by s square plus a square. Taking LCM, we can solve this. So when we take LCM, the LCM is s square plus a square. This outer term remains the same. So this gets multiplied with this 1. So in the numerator we have s square plus a square plus a square minus s square. This plus s square and minus s square gets cancelled and a square plus a square turns out to be 2a square. So it because both are plus, it gets added up and it becomes 2a square. And so we will be having this term as it is outside and 2a square in the numerator, in the denominator s square plus a square. Again multiplying this inside, we will be having a into a square becomes a cube. So 2a cube divided by s square plus a square the whole square. So this is what we obtain as the solution. So hope you have understood all the 5 problems that we have solved here by using theorem 2, that is product of two functions where one of the function is t. In our next video, we will see similarly product of two functions where one of the function will be t and the other function will be square of the trigonometric term. So we will be solving 2 more problems on that topic in our next video. So kindly follow the next video lecture. Thank you.